Welcome to AI Unpacked, a 6-part series offering a light but accessible introduction to the world of artificial intelligence. We'll touch on the key ideas, turning points, and technologies shaping AI today without getting too technical. Think of this as a guided tour designed to give you just enough insight to feel more confident, more informed, and ready to explore the subject further on your own terms. Artificial intelligence sounds futuristic, even intimidating. But the truth is, it's already part of your life. Every time you unlock your phone with your face or ask Alexa to play music or get a movie recommendation on Netflix, AI is working silently in the background. In this first episode, we'll break down what AI actually is, where it came from, and how we got from a summer workshop in the 1950s to the generative tools and chatbots reshaping our lives today. Before we even had a name for artificial intelligence, there was Alan Turing, a mathematician, codebreaker, and one of the most original thinkers of the 20th century. During World War II, Turing worked at Bletchley Park, where he helped crack the German Enigma code. It was a turning point in the war, and many historians believe it saved millions of lives. But beyond the spy drama, what Turing built was essentially an early computer, paving the way for modern programmable machines. His device could be reconfigured to solve different kinds of problems, a key step towards the kind of flexible intelligence we now try to replicate in AI. In 1950, Turing posed a deceptively simple question: can machines think? And instead of getting tangled in philosophy, he suggested a test. What if you had a conversation with a machine and you couldn't tell whether it was a person or not? If it could fool you, that is, if it could act intelligently, did that count? This became known as the Turing test. It was less about whether a machine was really thinking, and more about whether it could convincingly behave like it was. That shift from asking what intelligence is to focusing on what it does still shapes how we think about AI today. Tragically, Turing never lived to see how far his ideas would travel, but his influence runs deep. The Turing Award, often called the Nobel Prize of Computing, was named after him. And in 2018, it was awarded to a guy called Geoffrey Hinton, a British-Canadian psychologist turned computer scientist, often called the godfather of deep learning. In many ways, Hinton and others picked up where Turing left off, chasing the same idea: machines that could learn, adapt, and maybe one day think for themselves. The term artificial intelligence was originally coined in 1956 at a now legendary summer workshop held at Dartmouth College in New Hampshire, USA. The proposal, written by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon, boldly claimed that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. The founding thinkers believed that given enough time and resources, machines could mimic human reasoning. Early research focused on symbolic logic and simple rule-based systems. These programs could play games like checkers, or drafts as we call it in the UK, or solve basic algebra problems. However, excitement soon gave way to reality. The 1950s and 60s were limited by the era's rudimentary computing power, tiny databases, and high expectations. Machines simply couldn't process the complexity of real-world information. AI's ambitions were well ahead of its time. The 1970s also brought a chill. After lots of initial enthusiasm, the limitations of early AI became plainly clear. Funding dried up, and researchers drifted toward other fields. This period, known as the first AI winter, was followed by a second in the late 1980s, when expert systems failed to deliver on their commercial promise. Governments and businesses, weary of the hype, withdrew their support. These cycles of boom and bust have shaped AI's story. Overpromising and under-delivering has been a repeated pattern. Then came the internet, and with it, a torrent of data. In the 2000s, the game changed entirely. Suddenly, machines weren't starved for information. They were drowning in it. Emails, photos, video clips, sensor data, voice messages, all of it could now be used to train algorithms. This data boom coincided with a surge in computing power thanks to advances in hardware technology. Training a model that once took months could now be done in days or hours. AI moved from lab-bound theory to practical application. At the center of this technology growth is the GPU. GPU stands for Graphics Processing Unit. Originally built for gaming, GPUs are like industrial conveyor belts for data, able to process thousands of small tasks at the same time. To understand the difference between a GPU and a CPU, think of a CPU as a master chef preparing a 5-course meal alone, skilled but limited to 1 or 2 dishes at a time. A GPU, on the other hand, is like having a kitchen full of cooks, each handling a single repetitive task: chopping, stirring, baking, all in parallel. For AI, which involves performing countless mathematical operations at lightning speed, this kind of parallel coordination is essential. In training large models, GPUs enable the system to ingest and crunch massive databases, whether it's analyzing millions of photos, interpreting speech, or predicting the next word in a sentence. Without them, modern AI would be stuck in first gear. And this is also where companies like NVIDIA have come to dominate. Originally a graphics card manufacturer for gamers, NVIDIA's chips now power many of the world's leading AI systems. Their proprietary architecture, which allows developers to harness GPU performance for AI, has been a game changer in making large-scale deep learning practical and scalable. To put this into perspective, in 2023, the world generated over 330 million terabytes of data every single day. That's equivalent to around 40,000 times the data stored in every book ever written. By the end of 2025, that figure is expected to exceed 460 million terabytes a day. That's like producing the entire contents of the British Library more than 300,000 times every 24 hours. A major leap came from the creation of neural networks, computer systems inspired by the way human brains work. These networks learn from data. The more data they are exposed to, the better they get. And I'll explain more about these in coming episodes. In 2016, AI had a pivotal moment. And let me explain why. Back in 1997, IBM's Deep Blue computer famously defeated chess grandmaster Garry Kasparov, marking a turning point in public awareness of AI's capability. But chess, while complex, is still relatively structured and finite in terms of possibilities. The real shock came when nearly 2 decades later, DeepMind's AlphaGo defeated Lee Sedol, one of the greatest players of the ancient board game Go. Unlike chess, Go has an astronomical number of possible positions, and its gameplay relies heavily on intuition, creativity, and long-term strategic thinking. At the time, experts believed AI wouldn't master Go for another decade at least. AlphaGo didn't win by brute force. It used a blend of deep neural networks and reinforcement learning, training by playing millions of games against itself. It learned not just from data, but through experience, adjusting and improving its strategy over time. The result was a style of play that surprised even top professionals, at times bold, unexpected, even beautiful. Lee Sedol won only 1 game in the 5-match series. Afterward, he said he had never seen moves like the ones AlphaGo played. It was a wake-up call to the world. AI wasn't just catching up, it was beginning to outthink us in fields we once considered uniquely human. Sedol was so stunned, he retired shortly after. It was a cultural moment, proof that AI could master complexity and outwit human intuition in domains once thought unreachable. Despite all the headlines, it's important to remember that current AI isn't conscious. It doesn't think, feel, or possess goals. What it is extremely sophisticated pattern recognition. AI can mimic conversation, generate art, and beat champions, but it doesn't understand the meaning of the words it uses or the implications of its actions. That's why alignment, getting AI to behave in line with human values, is such a pressing issue. As we continue this series, we'll explore both the potential and the pitfalls of these systems. The future may be automated, but it's up to us to steer the direction. See you in episode 2.